When it says to find the discriminant, what is the discriminant? Absolutely correct. B squared minus 4ac. This is part of the quadratic formula. When you have the quadratic formula all written out, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. This part right here is our discriminant. So before we actually find the discriminant on number 1, it says determine the number of solutions from this information. So I want to know, once we go through and we find the discriminant, we have a number, we've done b squared minus 4ac. If my discriminant is bigger than 0, if it is a positive number, what does that mean about the number and type of roots we're going to have? How many roots will we have if the discriminant is a positive number? We're going to have 2. Would they be real roots or imaginary roots? If I have a positive number underneath my square root, is that a real or an imaginary thing? Real. So I'm going to get 2 real roots if what's underneath the radical is a positive. What about if the discriminant, the part underneath the radical, comes out to be exactly 0? Remember, the discriminant is the part under the radical. So if all of this cancels out and I have a 0 under there, what is the square root of 0? 0. Square root of 0 is 0. And then I'm supposed to add something to it and subtract from it. So let's just pretend for a minute that this was a 5 up here. What is 5 plus 0? 5. What is 5 minus 0? Still 5. So if I add 0, if I subtract 0, do I actually get 2 different things? No. So how many roots would I have then? Just 1. Would it be real or imaginary? Real. So if I have a positive number under my radical, I'm going to get 2 real roots. If I have a 0 under my radical, I'm going to have 1 real root. What about if I get a number less than 0, a negative number? What happens if we have a negative underneath our square root? Imaginary now, and it's going to be 2 imaginary roots. The only way we get 1 root is if it's 0. This is 2. We call them complex or we call them imaginary roots. Those get used interchangeably. So 2 complex or imaginary roots here. All right, so now let's actually dig into our bell work. We're going to do b squared minus 4ac on number 1. What am I going to use in the place of this b right here? What number will I substitute in? -9 right here. Here's my b value. So I'm going to have -9 squared minus 4 times, what are we going to put in for a? -4, this piece right here. What are we going to put in for c? -7, this piece on the end. And now we have to simplify this. Order of operations says I do what first? What do we do first? We do our exponents before we do any multiplication or division. Do we have any exponents? Yes. I have this squared. What does it mean to square something? Times it by itself. So if I do -9 times another -9, what do I get? 81. Then I have to multiply these pieces together. What's -4 times -4? 16. What's 16 times -7? -112. What is 81 minus 112? -31. That is my discriminant. So the discriminant is -31. What does that tell me about my solutions then? Two complex solutions, because this is going to go underneath my square root sign. If I have a negative underneath my square root sign, that means I have imaginary things or complex things. So we're going to get two complex or two imaginary roots. So far, so good? All right. Look down at the next one. We're supposed to determine the number of solutions. They didn't give me an equation like they did up there. So how am I going to know what the discriminant is? It's already there. What is it? 84. This right here is my discriminant. So if my discriminant is 84, is that positive, negative, or exactly 0? Positive. I have a positive number underneath my radical. What will that mean about my solutions? Two solutions. What kind are they? Are they real or imaginary? Real. Two real solutions. Last one on the bell work for today. They gave us a graph. They asked me how many solutions are being shown on the graph is the first question. How many solutions is this graph showing? 1. Right here. Because what's a synonym for solutions, for roots? X-intercepts, zeros. This is my one and only solution. Because I see only one x-intercept. All right, so I'm going to write that down. One solution. Is that a real solution or an imaginary solution? Real. Do imaginary things show up on the x-axis? No. So one real solution. And then they said that I'm supposed to find the value of the discriminant. How in the world can I tell exactly what should be underneath the radical if all I have to look at is that? It has to be 0. Remember, this is the only place where we get one solution, is if my discriminant is exactly 0. If it touched the x-axis in 2 spots, if there were 2 solutions, then all I would be able to say is that it's a positive number. I wouldn't know the exact value. Same thing if I see a parabola and there's no x-intercept shown. I could say it's a negative number, but I wouldn't know its exact value. If I see one x-intercept, then I know my discriminant is 0. All right. Please go ahead and pull out your reviews for the test. I passed several of them out to people that weren't here on Friday or that misplaced theirs. I want to do the first problem with you, and then I want to give you guys work time to work on the remainder of this. Yes, ma'am. Test is Thursday. So we have class today to review, class tomorrow to review. Wednesday, you guys have the PSAT in the morning. That'll be 4 hours of testing. I'm not doing anything formal in here. You guys are going to need a brain break. You can use that time to study. I'll still answer questions if you want, but I'm not going to do any formal lead instruction at the front of the class because I think a lot of people need a brain break at that point. And then we'll take our test on Thursday. Yes, sir. Another copy. We'll have to wait until I go over this first part. I just sent some to the printer and I can go and pick them up at that point, okay? So maybe take notes on a spare sheet of paper so that you can transfer that to your review as soon as I get that for you. All right, so the first thing I want to talk about on here, look up at the very top of your page. See all those formulas up there? You guys will get to use those on the test. It's printed at the top of the test just like it's printed here. I want to make sure that we know what each of them are. Because if you don't know what they are, you don't know how to use them. This one right here, this is our general form. That's our ABC form. The second one over, the one that has A, H, and K, this is your vertex form. Third one over, and it really should have an A right here in front. This is your factored form. So those are our three forms for quadratics. Does anybody remember what we use this for? Axis of symmetry. And the axis of symmetry tells us our H value. So in my vertex form, axis of symmetry goes right through the vertex. So if I do axis of symmetry formula, it gives me the X part of the vertex. It gives me H. What is this thing over here? Quadratic formula. I will give you all 5 of those things up at the top of your test on Thursday. They won't be labeled. That's why I'm taking the time to label them right now so that you know what they're each for. I can get one. I just sent some to the printer. So maybe take some notes on scratch paper for right now, and then I'll give it to you. First thing they want me to do here is to find the zeros. Can you guys give me some synonyms for zeros? X-intercepts. What else? Solutions. What else? Roots. So when I go to look at this graph, and they want me to tell them the zeros, where am I looking? Yep, look on the x-axis. So I see one right here, and I see one right here. These are my zeros. What are the ordered pairs for those zeros? -1, 0. Yep. And 5, 0. You could write them as x equals -1, x equals 5. You could write them as ordered pairs. With the way they wrote the question, if you just wrote -1 and 5, that would be okay. I want to make sure that we know all the different ways to recognize them, because if it shows up in a multiple choice question, I want to make sure that you know how to pick out which ones are correct. All right? So my x-intercepts, if they're written as ordered pairs, the place on the x-axis comes first, and then a 0 for the y spot. Where is our vertex? 2, -9. Right down here is our vertex. Where's the y-intercept at? 5. Close. 5 would be here. -5. Here's my y-intercept. If you write just -5 on that line, that is correct. How would it look if it was written as an ordered pair? It'd be 0, -5 for your y-intercept. Be careful here. Axis of symmetry is a whole equation. Yes, ma'am.
Vertex, is it always going to be the minimum, whatever?
It'll either be the minimum point if it opens up like a cup, or if it opens down like a frown, then it would be your maximum. Yes, that's true. Axis of symmetry, I need to write this as an equation. Come up here and look at our axis of symmetry formula. What does it start with? X equals. So when I go to write my axis of symmetry, I also need to start this with an x equals. X equals what? Which part of the vertex? Because we've got two numbers in our vertex. We've got 2 and -9. It's not necessarily a positive or negative number. What did we just say here? X equals. I don't want an intercept. We said we're looking at our vertex here. Which of these is the x part? 2. X equals 2. It's always going to be the h value. So when I look at my vertex, this piece is h. So that's how we got our axis of symmetry here. Make sure you put the x equals part on there. It is really, really important because the axis of symmetry is an equation. If you don't put the x equals part on there, it will be points off, and I don't like taking points off. All right. The last part of this question is why I wanted to make sure that we definitely did this together. They ask us to write all 3 forms for this parabola. Does this parabola open up like a cup or down like a frown? Up like a cup. So this opens up, which tells me that the A value is positive. For today, for this example, we're going to make an assumption here. We're going to assume that our A value is equal to 1. I know it's a positive because it opens up like a cup. We're just going to assume that it equals a positive 1. Let's write our vertex form first. Vertex form for any parabola is y equals a times x minus h squared plus k. And we're going to substitute in pieces for a, h, and k. What did we just say we're going to assume A is equal to? 1. So I'm going to put a 1 where A is. And then I have x minus, what should I put in for h? Yep, x minus, and now I need my h value. What is that number? 2. So it's going to be x minus 2 squared plus my k value. Where's my k value? Negative 9. It's the other part of the vertex. This part right here is k. What operation is happening if I add a negative number? That is the same as subtraction. So my vertex form, if our A value is 1, we oftentimes don't see it written down. If you want to still put the 1 here, that is totally fine. But when our A value is 1, we often don't see it. My factored form, y equals A times x minus m times x minus p. M and p are just stand-ins for those numbers. We are going to look at the roots, at the zeros, at those x-intercepts. So y equals, what's our A value again? 1, so y equals 1. And then x minus, give me one of the roots that we had. Negative 1. And then I have another factor that's set up the exact same way. X minus, and I need the other root. 5. When I subtract a negative number, that's the same as what? Positive, as addition. So for my factored form, I have y equals, since my A value is 1, I usually don't see that written, x plus 1, x minus 5.
Does it matter if you put the 1? Just put the 1 on the test?
If you put what?
Like the 1 on the test, like, will you take points off? Or
Will I take points off? Sorry, I don't.
if I put the 1, like if you put the 1?
If you put x plus 1 or x minus 1?
No, y equals 1.
Oh, I understand your question now. I apologize. The question was, if you put the 1 in for the A value, would I take off points? No, I would not. I'm totally fine for you to write in the A value on all of these forms. That is totally fine. That is not incorrect. If A is anything other than 1, it has to be written there. So if your A value is 1 and you want to write that in so that you just like know that you made sure to do that part, that's totally fine. Yes, sir.
But would it matter if you put x minus 5 first?
No, that wouldn't matter either. Good question. So the question was, does it matter if we have x plus 1 and then x minus 5, or can it be the other way around? It can be the other way around. Yes, that would be just as correct. Yep. The reason for that is because when I'm multiplying two things together, let's think about it with just numbers. If I do 2 times 5, what is that? What about 5 times 2? Still 10. That's why I'm allowed to write it down in either order for my factored form. Because in between those parentheses, we are multiplying things. All right, we've got one last thing to do here. General form. This is the one with A, B, C. This is the only one that I can't look at the graph and grab all the numbers that I need to. So I'm going to use one of these other forms, either my vertex form or my factored form, and I'm going to distribute and combine like terms. I like to use my factored form to do this because it's usually easier. All right, so if I had y equals x minus 5 times x plus 1, we're going to use the distributive property. What is x times x? X squared. What is x times 1? 1x. Then I have to take this negative 5 and I have to distribute that as well. What is negative 5 times x? Negative 5x. And negative 5 times 1? Negative 5 or minus 5. Are there any like terms there that I could combine together? Yes, this positive 1x minus 5x. What do I get if I combine those two pieces together? Negative 4x, yes. So y equals x squared minus 4x minus 5. Is this somewhere special on my graph? It's my y-intercept. So I can find C from the graph, but I can't find my B value unless I use one of my other forms. All right. There was a slight typo on your test review. It's on problem number 4, so it's on the back of this page. Snap a quick picture of this if you need to, because I want to show everybody where this typo was. Problem number 4 was in the middle equation that had the mistake. And after the 4x, it should have been a minus 21 instead of a plus 21. Should have been a minus 21 instead of a plus 21. To the best of my knowledge, that is the only typo on the test, or on the test review, sorry. You guys have the remainder of the class period to work on the review. I'm going to go pick up the extra reviews off the printer for those of you that still need them. And I do have some hints for you guys if you get stuck. So if you need help on the test review, each problem number from the review and the pages in your book that you can go look at so you can find examples for help on how to do those problems. Okay? Tomorrow I'll take questions over any of the problems that you want to see me go through. But you've got the rest of the time today to use as work time. If you want to work in partners or small groups, or you want to listen to music while you're working on the review, you may absolutely do so.